Hello, everyone, and welcome to the second in our series of developer webinars. So for those who aren't aware, this is a series of Refinitiv hosted webinars that we're holding for our developer community, really to try to share as much of the knowledge that we accumulate as possible across the different activities and projects that we run at Refinitiv. So today we're going to be discussing how to build machine learning pipelines on AWS with SageMaker and step functions. And that's essentially to help you tackle the same machine learning automation challenges that we face here. So before we jump into today's session, just a few housekeeping points to call out. So firstly, you should be able to see a little Q&A box on your screen. Please feel free to submit questions at any point during the webinar, and we'll make sure that we've got time during the session, but also at the end, we'll try and allocate about 10 minutes to address as many of these as possible. Secondly, we do find that most technical issues can actually be resolved by just refreshing your browser. But if that doesn't work, then do use the same Q&A box, and one of the Refinitiv team will be able to help. And the last thing to mention on here is that we will be having polls sprinkled across the whole webinar. So do answer those and make your voices heard. So with that in mind, it might be a good moment to test the poll functionality and find out where you're all joining from. So I'll give you a few seconds to answer that. I'm personally in a surprisingly warm London in the UK. Okay, let's see where you all are. So, wow, not sure the poll functionality is working, unless really 50% of you are in the US and 50% in other. But welcome, wherever you are. Okay, so agenda-wise, I'm going to give you a whistle-stop tour of Refinitiv Labs. The rest of the session is going to be a much more technical deep dive. So we're going to have about 45 minutes to really dive into how to leverage, firstly, how to leverage AWS services to build machine learning pipelines. Next, we're going to be talking about actually defining machine learning pipelines in code. And then actually, lastly, how to integrate with other AWS services. And then we'll open up for a Q&A to answer any of the questions that we haven't been able to answer during the webinar. And this is who you're hearing from today. So I'm Laura Sartanar, and I manage strategy and partnerships for the labs in EMEA. But the real star of the show is Yevgen Goychuk, and he is a senior software engineer at labs in EMEA. And Yevgen will introduce himself shortly. But who are Refinitiv Labs? So although Refinitiv is a fairly big team of, I think, about 18,000 people, the labs are actually relatively small. So we're a team of about 40, and we're based in London, New York, and Singapore. We're fairly cross-functional. I think it won't surprise you to hear that we have full-stack developers, we have data scientists and data engineers, research scientists. We have a design and user experience team who is really focused on kind of keeping us on the straight and narrow and making sure that everything we do is completely customer-driven. And then we have ecosystem people. So that's people focused on strategy and partnerships, like me. But really our ultimate mission is to help our customers with their evolving needs and to help drive innovation across Refinitiv by actually showcasing the art of the possible with financial data and emerging technology. And we do that mostly by actually building proof of concept, which we test in 10-week sprints. And we test iteratively with the market and with our customers. And that's mainly to make sure that we don't fall into this trap of technology looking for a problem, which I think is fairly easy to do in the world of innovation, as I'm sure many of you know. But I'm sure it won't surprise most of you to know that from an emerging technology standpoint, we spend most of our time actually leveraging machine learning. And that's probably no surprise to those of you that know that ultimately the AI story is a data story, and that Refinitiv is one of the world's largest providers of financial markets data. I mean, I found out recently that we actually deliver, I think, about 150 billion data updates to our customers each day, which I think is fairly staggering. But one of our biggest pain points that we face within the labs and that we know that our customers are facing is actually how do you reduce the time between ML model creation and deployment. So we're constantly looking for new ways and new tools and technologies to actually train and deploy models automatically and without human intervention. And that's exactly what Yevgen's going to focus on today. So this machine learning pipeline. But let's do some level setting first. So before we hand over to Yevgen, and given that this session is really about SageMaker, AWS SageMaker, it would be good to know how many of you are actually using SageMaker. And if you didn't answer before, please do answer now. It would be good to see some diversity here in the answers. So I'll just give you a couple more seconds here. But do you currently use SageMaker? No, but planning to. Currently evaluating, yes for internal purposes, or yes for internal and customer-facing purposes. So let's see what we have here. Okay, a bit of diversity, but interesting to see that actually most, I think 87%, Yevgen, are actually not using SageMaker today. What do you make of that?
Well, then you will learn something new today. Yes. Interesting. Okay, so I'm Yevgen Gaichuk. I'm a software engineer in Refinitiv Labs. And today we're going to talk about machine learning pipelines in AWS. And machine learning to me is an approach when you automate machine learning activities into a series of steps to ensure continuous deployment or continuous work of a service or application backed by machine learning. And it can be part of your deployment pipeline, but also you can trigger machine learning pipelines as a part of your application logic. And that is what I'm going to demonstrate today. And today we'll learn how to use SageMaker and step functions and other AWS services to build machine learning pipelines. You will learn how to define a step function related part of machine learning pipelines in the code using Step Functions Data Science SDK from Amazon. And you will learn how to integrate with other AWS services to trigger the execution of the pipeline on various events. For example, when you're training code changes or when you're training data changes. And I'm going to show it through a demo application, which does stock price anomaly detection. The simple application which shows you the price chart for selected stock for selected day and highlights price anomalies when the price changes quickly in short period. I used one class SVM algorithm from scikit-learn purely because it's quick to train and the output artifacts are small, so I have chance to demonstrate it in the pipeline during the demo. So I'm less concerned with the correctness or accuracy of the model, although it highlights anomalies where it's supposed to, where the price changes rapidly in a short period of time. And that's how I structured features for this. That's what the model was trained for. And the training data is our own Refinitiv tick data, aggregated into 10-second intervals with open, close, high-low, like in candlesticks. And we're going to use quite a few AWS services. Main will be SageMaker and step functions, but I will highlight when and how we're going to use other services as well. And you know that SageMaker, even if you don't use it, probably you've heard of it. It's a platform on AWS for various machine learning activities. You can use it for training and deployment your models as HTTP endpoints, for hyperparameter search, model validations, etc. And Step Functions is a service that allows you to integrate different other AWS services in a workflow, a serverless workflow in this case, because you don't need a dedicated server that would run yourself. It's a service that you only provide a definition of your workflow. The rest of the services, we use it in various integrations. So the Step Functions workflow is quite simple. It consists of two major steps: SageMaker training job, which produce a model from training data, and then the next step is to deploy that model as a live HTTP endpoint that our demo application uses. And on each of these steps, I provide my own code, packaged as Docker image. So I have training image and I have inference image that SageMaker is going to use. And the integrations I'm going to show are the following. First is when you change your training code, or any code in the repository, the code pipeline and code build, AWS services, are set up to pick up this change and start build process, and code build will package training code and inference code into these images, into 2 Docker images. We'll push them into AWS code repository, and then it also create or update, if you run it for the second and subsequent times, create or update step function workflow from the definition in the code, and it will also execute it. So when you execute, then this workflow that you've seen on the previous slide will run, and will use latest images to deploy newest model machine learning endpoint. And the second integration is when I update training data in S3 bucket, where we have training data, and that will trigger through CloudTrail and EventBridge and Lambda, it will start execution of the same step functions workflow, and it will result in a model being, well, more models being deployed from the new training data. Basically, before we dive into the code, I wanted to ask you more questions. So I wanted to know if you ever used step functions with combination with SageMaker. It's interesting how many people are exploring this way. All right. So let's see what are the results. So some of you tried that. That's really good. That's really interesting. I'm sure that all of you, or like many of you, most of you will learn something new today. So without further ado, I will share my screen and we'll dive into the code. Right. So the first thing I'll show you is this demo application. So it's very simple web page where you specify an instrument and a date. It shows the price curve and highlights anomalies. And as you can see, it highlights way too many anomalies. They're supposed to be rare. And this is deliberate. It's something that we're going to fix during this demo. And another thing we're going to change is the endpoint, the SageMaker endpoint that this application uses. Even though it runs locally, it uses the endpoint in the cloud. So the other thing we're going to change is be able to get the predictions for Amazon as well. Currently, the training data, it's deliberate as well. The training data is only for Tesla. And this endpoint was trained only with a model for Tesla stocks. So if I try to choose Amazon, I would get an error. But if I place new training data for Amazon, it should fix the problem. And before I go into the code, I also wanted to show you the SageMaker, the typical SageMaker example, just to highlight the differences between what you see in this example and what you'll see in my project. It's Iris training notebook. It uses scikit-learn, and very typical thing is that you use estimator, which is, in this case, it's scikit-learn estimator. Estimator is an object in SageMaker that is responsible for setting up the environment for that framework that you use. For example, scikit-learn estimator would give you an environment where you can run Python script, and that Python script would be able to access scikit-learn. And you specify which machine instance you should use. And the script, you can also see it in the notebook right here. This script it doesn't know about SageMaker, it knows about scikit-learn. You can run it locally without SageMaker providing input parameters through command line, but also it checks the default values in certain environment variables. And that's how SageMaker happens to communicate these values to the script. So because of these parts, you can run the script in SageMaker estimator as well. Otherwise, it's just a plain scikit-learn script. So once you define the estimator, you call feed, pointing it to train data, and that is command to SageMaker to create a new server and to run the training job there. Then you use deploy method on estimator to deploy it as an endpoint. And in this case, you also specify a machine configuration and how many machines you want that endpoint to be running on. And the important thing here is that in both cases, you specify that it will be running somewhere else. So in a sense, nothing interesting happens on the machine where this notebook runs. So what's the role, what's the significance of this notebook? So the answer is, this is your machine learning pipeline, where you have a series of steps that lead to a live endpoint. And, well, is it the best way to keep your pipeline? So I'd argue it's not. Depends what you want to do with this code. It's good to, so Jupyter notebooks, they were created for human eyes. And it's good to share knowledge through notebooks, but they are not designed to be as deployable artifacts that you can integrate the rest of your application with them. And as you might guess, that's what I'm suggesting to replace with step functions workflow, what happens in this notebook. And that's what I do. So similarly to SageMaker notebook, this is my training script, which is also plain scikit-learn script. It doesn't know about SageMaker. It knows about one class's VM. I use it right here. And this parameter, by the way, is the proportion of abnormal data that it expects to find. And the reason the pipeline, the reason that the endpoint is too sensitive is because this parameter is way too high. So this is the first change I'm going to make. I'll request it to find less anomalies. And if you look at the rest of the script, it's also very similar to what we've seen in the notebook. You can provide the data through command line, and it checks input and checks environment variables. And it also checks all the files in the training data folder, and it trains one model separately for each instrument. If I don't provide instruments through command line parameters, it will train through all the files that it finds in the folder. So if I run it locally on my machine, where I have two Parquet files, one for Amazon, one for Tesla, it will produce two models, one for Amazon, one for Tesla. And now the only thing I need to do is to package this code in a way that SageMaker can run. I'm going to use generic estimator, not scikit-learn estimator. So instead of providing this as a script, I will package it into Docker container and provide a Docker container. And by doing it this way, I can use any framework, anything. It might not be scikit-learn, it might be anything that you specify. So you can have any dependencies, and you can use them in the training script. I'm going to make another change and push both changes, and I'll keep explaining what's happening, what in this code is happening. So this is another file where I define a pipeline itself, similar to the notebook. And here I'm presumably wearing another hat. I'm as a DevOps engineer, and I decided that the endpoint for the pipeline is running on weak machine. It's too weak, and I wanted more powerful machine. So I'll change machine definition for the endpoint. And I'm going to push both changes. I suppose they should be done as separate commits, but I'll just do it as one commit. That's paranoid. model. Right. So this should trigger the pipeline, and we'll check it in a minute. And meanwhile, I will go through the code, just explaining what it does. So we have training script. Now we need to package it so that SageMaker can run it in Docker container. I use SageMaker containers project, which is, yeah, you can find it in GitHub, and it says that there are even newer things, SageMaker training toolkit and inference toolkit that you can use to package your own training and your own inference code. But SageMaker containers works perfectly well. So once you have this line in your Docker file, it sets up, it creates a necessary folder structure, AltML, for example, that SageMaker expects to find. Then, as you would normally do, you install dependencies, copy your training script, your training and the feature script, and feature script is separate just because on the serving side, I use the same feature script, so the data comes through the same transformation when I train the model and when I deploy it as well. And then I point to a training script. So when I build an image using this Docker file, that the image you can run that image in SageMaker. And on the serving side, I didn't use the inference toolkit. I just followed the guide, use your own inference code, which boils down to basically one sentence. You need to implement a web server with two endpoints, invocations and ping on this port. And that's what I've done on the server side. Invocations and ping. I use Fast API. You can use Flask. Fast API is just a newer API in Python for newer framework in Python to create APIs. It supports asynchronous Python. It supports Swagger definitions out of the box. So check it out. And the predictions is the invocation endpoint, what we call predict, is what outputs predictions. And in predict.py, that's where it basically turn endpoint into what's called multi-model server, because I have multiple models, one model per stock, and it's a good solution in this case because you don't want to serve, you don't want to spin up 500 machines if you analyze 500 stocks. You'd rather have multi-model server, and it's not exactly the same as multi-model server in SageMaker now, but nevertheless, it has multiple models, and this code chooses which model to load depending on the request. And features.py is the same file that I use in training. So for the serving side, the Docker looks probably even simpler. I install serving dependencies, which is Fast API and scikit-learn, copy a few files, specify an endpoint, and that's it. Now there's a third part in the project, which is workflow.py, where I made the change. That's where I define my pipeline, and that's where I use data science, step functions data science SDK. It looks similar to the notebook. You can see estimator object here. I'm giving it training image, not the script. That image that we built from training file. Specify where I want to train it. Now I don't call fit immediately on this estimator. Instead, I'm defining something called training step. And steps are the concepts from step function service. So that's how you define your workflow as a series of steps, each of which call to a particular service or does some action. And in this case, training step, I provide estimator for training step, and I'm pointing it to training data. So when the workflow with this step will be executed, that workflow will call, that this training step will call fit on estimator, and this training step will start execution of the training. And I provide training job name, providing it from input parameters. It's not just a constant here, because that would not work. SageMaker requires unique names for training jobs. So this means that every time when I start this pipeline with this step, I need to provide input parameters for the pipeline. One of them will be training job name. Then I use the trained model to redefine serving image. By default, the serving image is the same as training image. I want to specify my very specific serving image, so I can override it. And the model step is when SageMaker registers model with this name and this serving image and this binary. So this triplet is a model in the parlance of SageMaker. And then endpoint configuration step. And by the way, model name also comes from input parameters. An endpoint configuration step is where I specify that model with this name should be running on this infrastructure. And that's where I made my change. I made change to endpoint configuration. And that combination of this model on this infrastructure will have this endpoint config name. And then endpoint config step is where I define, it's a catch step actually. So it will try to create model, and first time, when you run it first time, it succeeds to create endpoint. All the subsequent runs, it would fail, so we'll have catch step, which is update endpoint, which is the same step with a different parameter. And then I basically chain these steps into a sequence, and that becomes workflow definition. I need to provide this workflow definition to step functions service. If I don't do it in Python code, then, well, normally the workflow definition for step functions is a JSON file. You would have to define your workflow using JSON, and if you work with, for example, CloudFormation, you know that definitions in JSON, when they are slightly more complicated than very simple, they become very difficult to reason about. So it's way easier to define workflow using Python code, and with nice integration with SageMaker Python SDK, than creating JSON file. So that definition, I'm passing that definition to step functions service for update or creation of the state machine. And then there's this function is where I execute this workflow. That's where I provide input parameters. Training, serving image, job names, model names. The only stable name is endpoint name. It doesn't depend. The rest depends on the timestamp. Endpoint name is something stable because it's what is referenced by clients. So you want stable endpoint name, even though you keep changing models behind the scenes. And by the way, when you update an endpoint with this step, it happens with zero downtime. So if you have a live endpoint that serves some model version and you update that endpoint, SageMaker will spin up new server with updated model on the background, and will wait till it spins up, and all this time your endpoint will be live and will be replaced with zero downtime. That's something nice you get from SageMaker out of the box. Zero downtime updates and load balancing if you have more than one instance. So if we look at the main file and the main part of the file, that's where we define the definition for the state machine for the pipeline, where we define the workflow and update it in the service, give it time to sync in changes, and then we execute workflow. So where do you run this file? You can run it locally. If your AWS SDK configured properly, it will, by all means, it will just create an update or update workflow, and it will run it. But the correct place to run this code is on your build box. You want to run it every time when your code changes. And that's what I do in this project. I use code build, AWS code build, and for it to run build script, it needs to find a file called buildspec.yaml in the root of your repository, or you need to specify where it is. And in that file has what you probably expect to have. So it builds training image using that train Docker file that I showed you before, and it builds serving image using serve Docker file, and builds and pushes them to AWS repository. And then it runs workflow.py. And in that workflow.py, that's what I showed you here, I use these training and serving image names. Can parameterize it even better, but yeah, it works. And for this workflow.py to run on the build box, I need to install workflow dependencies there. And that workflow requirements, that's where I put AWS step functions data science SDK. By the way, I will show for a second, I will show the product page for the documentation page for this SDK. I'll get back later and point a few interesting parts in it. Okay, so this is the build script, and let's check how it progressed, how it went. So you see that the build succeeded 6 minutes ago, so it picked up changes in GitHub, and what passed it is code pipeline. So I defined a code pipeline in AWS code pipeline, which basically looks for changes in GitHub and pass it to AWS, to the code build. And if you look at the code build log, you will see that it executed that build script. So it installed Python first, then it built and pushed one image, and built and pushed another image. And in the end, it successfully executed step functions workflow. So let's see. Right, so it finished a few minutes ago. This is this execution in GMT time. If I go inside, I would find nice visualization of the same steps that I defined in the Python code. It went through update endpoint, not create endpoint, because I have live endpoint. And by the way, this is the definition of the same pipeline using JSON. So that's what SDK generates in the end, what it saved you from. Otherwise, you'd have to define it this way. And you could see in the execution the input parameters I provided from the script. You can see submitted and succeeded SageMaker training job. We can go from here directly to that training job. The correct infrastructure, correct Docker image. We can go even deeper and open logs for that training, and you will see there what you pretty much expect to see when you run it locally. So it was training on one instrument because we only have one training data file, and succeeded. And the last thing to check is the endpoint. So yes, endpoint is still updating. It takes time to create new infrastructure and deploy everything. So it will probably be there for 1 or 2 minutes. Meanwhile, I can probably answer one question. If you have questions, Laura?
Yes, well, I was going to remind the audience that you can ask as many questions as you like, but I don't think they need reminding, as we've had many questions come through, which can only be a good sign. So a few people, and I can actually answer this one, which is unusual, but a couple of people have asked about whether it's possible to get the complete script. And I can tell you that we will be providing code samples from today's session via GitHub in a post-event communication. A few people have asked whether the session will be available to revisit, and I can say, yes, you'll be receiving an email with the recording. But a question for you, Yevgen,
yes,
is, so when using AWS SageMaker, there's an assumption here that there's no need to have a database. Is that fair, given that it's got its own cloud database?
I assume it's about training data, and SageMaker uses S3 for training data. So you need to put your training data in S3 bucket and point SageMaker to that S3 bucket before for the training job to run. So yeah, in a sense, you don't need a separate database, but you need to provide training data in S3. And that is where SageMaker would output model as well on S3. So you need to provide S3 plus for training and for the model. Right, and the endpoint is in service. And let's check. So as you see, it picked up the change, way less anomalies. So the only thing I've done, I just pushed changes, if you remember. Now the interesting, oh yeah, I wanted to check one more thing. We've done 2 changes, and the second one is we updated the size of the machine for the endpoint, and as you can see, it's MLM5 large. That's what I specified in the script. So both changes were applied. Now I'm going to make a second change. I'm going to add more training data to S3 folder, and let me show the structure. So I have webinar SageMaker step functions, training data, and I have more training data, but in this folder, which is used for training, I only have one file currently. So I'm going to put another file there, and it hopefully will trigger integration, and then I'll explain how I've done that integration. So I will copy this file through command line. I'm copying Amazon. It's done. I refresh and I see this file here. And if I go to step functions, yeah, you see that something is running and it started just a few seconds ago. And I can go inside and see that it's on the model training step. If I try to go deeper into the logs, these logs will not be immediately available because it's still spinning up the machine. But we'll check in a few minutes. So no log stream, the machine is not ready yet. We'll check in a few minutes. And meanwhile, I'll explain how this integration is done. By the way, I don't know if I showed or not, but that's how it looks now. It's going to give an error, but when the pipeline finishes, it's going to be available live. So I will probably start with, for this integration, I will start with Trail. So the CloudTrail is a service that monitors AWS services. In a sense, you can define a trail. So you can say that I'm interested in the events that are happening with AWS services, and I want to turn them into a stream of data points that my application can analyze. And that is done by defining the trail. So when I define the trail, I'm saying that I'm interested in events with S3 service with this particular folder, and I want to I want to subscribe to these changes and react somehow. As you see, I tried to specify even a prefix here so that the trail would only deliver events for specific bucket, for specific folder in that bucket. That didn't work, unfortunately. Probably didn't spend enough time sorting out syntax, but I figured I managed to do this filtering in another place. I'll show it in a minute. So once you define a trail, you can subscribe to the trail in Event Bridge, in another service called Event Bridge. And that's what used to be called CloudWatch rules. So the CloudWatch rules is where you could subscribe to different events. And now it's a separate service, although you still see these rules through both consoles, through Event Bridge and through CloudWatch. And here, I'm basically saying that I'm interested in AWS S3 events deployed through CloudTrail, and I'm interested in the events put object and complete multi-part upload, and that is 2 methods to update your bucket, either through UI, through API, or in my case through command line is this one, complete multi-part upload. And in the event pattern, I'm also specifying that I'm interested in a bucket with this name, and here I can also say that I'm interested in the objects with this prefix. So I'm interested only in the changes to training data folder. Before I've done this, I went into a vicious loop because the pipeline would produce model and put that model. I set it up that it puts model to the same folder, and that triggered pipeline again, and it built and pushed and built and stored another model to the folder, and so this was running in endless loop. So be careful, use prefixing to scope your events. So with this definition, I can subscribe to changes only in training data folder, and that's what you specify what to do with this integration. And initially, I wanted to to start state machine directly. You can do this. You can specify state machine, the name of the state machine. The only problem is I can't easily transform AWS S3 event into input parameters that my pipeline expects. And you have some means here to transform parameters, and I could avoid Lambda function. I could directly call state machine, but I didn't have full control over which names in the parameters I'm using, and I wanted full control, and so I specified Lambda. So I'm calling Lambda here, and Lambda is very simple in this case. It's of 2 steps. It's basically define input parameters and call state machine with these input parameters. And as you can see in these input parameters, I don't even use S3 event because I'm not using anything from that. I'm only specifying timestamps. But you could, so that's the way to analyze which object was changed in the S3 folder and react somehow. And if you asking question why can't I just put all these the training and everything else in this Lambda function right here, the answer would be, of course, because it's long running processes, and Lambda function doesn't live that long. And you don't want to overpay for long execution. It wasn't even possible. So you need something that would asynchronously start these jobs with SageMaker, and that is what step functions do. What you can do here is just start the state machine. And so the training job has finished, and I'm looking at the training logs. And as you can see now, it's training on 2 instruments. Found 2 files, so it will train 2 models, finished for Tesla, finished for Amazon. I'm sure the endpoint itself is not ready. It's still updating. Yes, it's still updating. It will take a few more minutes. And meanwhile, I wanted to mention a few interesting things about step functions data science SDK. So they call data science, but if you look at the steps, they cover integration with multiple services, not only SageMaker. If you look at SageMaker, they have training step and transformation step and hyperparameters tuning. So you can use this SDK to define pipelines. That includes tuning step. And also, very recent addition is processing step. If you haven't heard of SageMaker processing, it was added relatively recently. To SageMaker, it was added in November, but step functions, they support processing steps only as of 2 weeks ago. And so the SDK also, it's very recent addition. And the SageMaker processing is where you package your pre-processing logic into Docker containers, similar ways as I packaged my training and my serving step. And in that Docker packaged processing, you can use Well, first of all, there are a few images already provided by SageMaker, scikit-learn processing and Spark processing. So you can specify those images and just give, for example, if you use Spark processing image, you can give it a Python file for Spark Py, and it will run pre-processing for you in this Spark container. It's similar to AWS Glue. It's basically an alternative to AWS Glue to use Spark on demand for your pre-processing. But what SageMaker processing allows you to do more than that is that you can use any custom logic. You can use any of your processing scripts and package it into Docker container and use it the same way in the pipeline. And also, if I go back to the steps, it also covers other various AWS services. So Lambda step, for example, or, well, Glue, Batch, ECS task. So you can use this SDK to construct pipelines with that cover various services, including databases and queues, and logical rules as well, like options, not choice, etc. Let me check. Nope. This one, yeah. Still waiting. Laura, I think I can answer more questions while we're waiting.
Great news, because we've got quite a few coming in. So the most recent question actually is, can we use an on-premise NVIDIA cluster that is accessible via an SRL-URM or SLURM scheduler as a target machine to deploy or run our models developed using SageMaker?
That's a great question. So it's basically how you specify to run your training job, how you specify to run a training job on local infrastructure, on-premise infrastructure. So one thing that comes to mind immediately is local mode, but that means you need to run the, so your build box, well, you can specify for an estimator, one of the parameters. Sorry, it's in the work folder Py. So for an estimator, one of the parameters, instead of these two, you can specify local mode. That means to run on this machine where you run this script. That one thing that comes to mind. Another, well, I would have to research that. That's very interesting. We probably will reply in the post-event communication. Okay.
Do we have time for another question, Yevgen?
Yes.
Yeah. So from the same audience participant, actually, really interesting question. Does loading the model in each call of the prediction method introduce substantial I/O, so input-output overhead, when the size of the model becomes huge?
In my implementation, it would, if the size of the model was huge. But, well, so first of all, in my case, the models are, they're really small, but you can use different logic here. You can cache or keep some least recently used cache to have a few models in memory, the most recently used, for example, models in memory, and the rest you would load on demand. So it's up to you. It's completely open code in this case, how you implement multi-model server. You can also implement multi-model server using standard SageMaker multi-model offering. So now for some time you can implement a multi-model server through SageMaker standard way. It's in service. Let's go and check. Yay, it worked. So all of them, I copied a new training data file through command line, but you can copy it. It might be a part of the application logic, like when other part of your application prepares training data and puts it on S3 bucket, and that triggers the pipeline. That was, in essence, the goal of the demo, to show these two integrations. And well, let's hear more questions.
Okay, brilliant. So do keep the questions coming in. I know we still have a few unanswered as well. But does SageMaker support some new machine learning libraries? For example, Cat Boost.
Well, the whole point, even if it's not, the way I've done this training script, you can use anything at all here. So you use Cat Boost or whatever, and you, well, specify it as a requirement, and in your training, in your Docker file, you install these requirements, Cat Boost or whatever. And if you use generic estimator, not specific scikit-learn estimator or TensorFlow estimator, generic estimator doesn't require script, it requires image, Docker image. So that Docker image with Cat Boost and everything else will be used for training, and whatever it produces to the output folder will be picked up by SageMaker, tagged, and copied to S3 as the output binary artifact. So yes, you can use Cat Boost, whether SageMaker supports it out of the box, so you don't have to create your own estimator. I don't remember, unfortunately.
We can have a look and get back to you on that one. And Yevgen, so we've got a couple of questions on integration, one on data integration and one on integration with the rest of the applications. So firstly, data. How is the data from Refinitiv actually integrated with SageMaker? So
I could use SageMaker processing to basically fold tick data into 10-second intervals. So that is the necessary pre-processing. It's to turn it into 10-second intervals. The only reason I couldn't do it in the demo, because I wouldn't have time to run it and to see it run to completion. But yes, I would use SageMaker pre-processing and probably Spark or something else to fold it, raw tick data into 10-second intervals. And it's not real time. So in this case, I'm not using the real-time stream. I would use tick data archive, because I need a few months of data to train model.
Great. And then actually about the rest of your applications. So someone's asked, how can I integrate the machine learning pipeline with the rest of my applications?
Yeah, so one of the ways is to extend your pipeline to include more different services. For example, you could integrate with SQS, and on some other event in your application, you put an event into message queue, and then you could create a subscription for SQS that would then trigger training. So you can trigger training not only on new training data or on code change. You can trigger retraining, for example, when you detect data drift from the monitoring, from the predictions that your endpoint currently serve. So extending your pipeline and including more services would be a way to integrate your application. Another way is, SageMaker pre-processing, I suppose it's more for, SageMaker processing is for pre-processing data more than anything else. So through other services and extending pipeline to connect to other services. That would be my answer.
Great. Just a quick and hopefully easy one, but can the code be run in Jupyter Notebook?
Yes, you can. If you run this code in Jupyter Notebook, for example, this workflow, what it would do is it would create a new step functions state machine here. And if you copy all that code, the last part will also execute it. But in this case, there's no point to use if you run it through Jupyter Notebook, there's no point in using step functions, because Jupyter Notebook itself, you can create a machine learning pipeline in Jupyter Notebook itself, as I showed in SageMaker SDK examples. The only difference is whether it runs directly from the notebook, whether it issues commands to SageMaker directly, or whether it issues commands through step functions. If you use notebook, for me, it doesn't make sense to use step functions at all. So they are kind of so notebook is for sharing the knowledge and running the demo, and step function state machine is when you turn it into productionalized product, when you make it the deployable artifact that you can integrate with, because you can't run easily notebook on different events, like when your training data is updated. There are ways, but there are better ways. So step functions is a better way.
Got it.
Hopefully,
Oh, sorry, Evgen. Last question before we wrap up. But is it possible to not run the machine learning pipeline on every code change?
Yeah. So this all comes to how you organize your branches. For example, my code change, I've done 2 code changes basically, and they're supposed to be different commits. One by data scientist who tested the script locally, another is by machine learning engineer. Sorry, machine learning. I mean the DevOps engineer. And it's completely possible that they would push this change into a branch that is not connected to the pipeline, and then upon integration, upon merging these changes into master branch, for example, only that branch would be set up in the code pipeline to start the demo. So in a way, you can pull several updates into one commit that then integration commit that then trigger pipeline, for example.
Brilliant. Well, thank you so much, Yevgen, and thank you also to all of you for joining us today and for sending in your questions too. I hope you found the session to be insightful and helpful, and hopefully we will see you at our next session, details of which you can find I think on your screen now, and if not, in your inbox shortly. Thank you, everyone. Bye-bye.
Thank you. Bye.